Okay, for this first review problem, we're going to solve this differential equation, dy dt equals t to the third minus 2y over t. And also find the domain of the solution if y of t naught is equal to y naught. First, we're going to write this as y prime is equal to t squared minus 2y over t, which we can then write as y prime is equal to 2 over t times y equals t squared. So we see that this is a linear differential equation in disguise. So we can use the standard techniques for solving linear differential equations. First off, let's figure out the integrating factor, mu of x. So mu of x is going to be equal to the e to the integral of 2 over t dt, where I took 2 over t here. I'm going to integrate that and then take e to that. Okay, so this is going to be e to the, okay, so this inside here is going to be 2 natural log t natural log absolute value t, pardon me, plus c. Now on this step, the undetermined constant is not required, so I'm not going to do that on this step, which is equal to e to the 2 natural log t like this. So that's equal to absolute value of t squared by the laws of exponents, and absolute value of t squared is just t squared all by itself. Okay, so that's that part of the answer. And so finally, y of t will be equal to integral of this t squared times, and I should have wrote mu of t here, not mu of x, I apologize, mu of t dt all over mu of t. So that's equal to integral of t squared times t squared dt all over t squared. So that's equal to integral of t to the fourth dt over t squared. So that's 1/5 t to the fifth plus c over t squared, which becomes 1/5 t cubed plus c over t squared. And so that is the answer. That's the form of the general solution. T to the third over 5 plus c over t squared. The question also asked for the domain of the solution if the initial condition is y of t naught is equal to y naught. Obviously, we have a slight problem here, which is that in this function here, this function is not defined if t does not equal 0. So the domain of the solution depends on what the initial t naught is. So the domain is going to be from minus infinity to 0 if the t naught is less than 0, because obviously t cannot equal 0 in this function. And the domain will be 0 to infinity if we have an initial t naught that is greater than 0. So here's our solution and the domain.